Okay, boys, here's another proof. What we're looking at is a different style where we're analysing the product of intercepts of chords that intersect, and we're going to show you that they are equal. So when we multiply the two chords and their components, you'll see that they're equal. So in this example, chord A to B and C to D, we're going to show that A to X and X to B, if you multiply them, they're going to be the same as C to X and X to D. This other word secant, okay, that's where we extend the chord outside of the circle to meet at a common point. In the case here, E to Y and G to Y, but just park that up for a minute. We'll come to that in the next, there's two examples that I'm going to use in this proof, and we'll consider that one later, but it's basically saying that that same property is true, that when you multiply the intercepts. So over the page, you'll see, I just want you to focus here on the left. Okay, in this case, we haven't got secants, we've just got chords, and we're looking at their intercepts. And like I said, we're proving that A to X times X to B is equal to C to X times X to D. So, in order to prove that this property is true, we have to consider similar triangles. So, have a look at the triangles AXC and the triangles DXB. We're going to prove they're similar using the angles. So if you consider AD as an arc, you should be able to see that this angle in here, C, and this angle here in B will be identical because of a previous proof where we showed that two angles lying on the same arc are equal. So that's one set of angles. The second set we get is if you consider the bigger arc CB, in which you'll see that this angle D and A are also equal because they lie on the same arc. The final angle we need to prove are equal in each is this vertically opposite angle, so DXB and AXC. By doing that, we've just proved that these triangles are similar. They're not congruent, they're similar. So one property of similar triangles is that the ratios of the sides are equal. So that if you look down here in the yellow, that's what I've highlighted here. So what we do is we line up the sides and we say, well, the ratio of A to X over X to D, so these two sides here, because they're the corresponding sides, is the same as CX over XB. And then finally you cross multiply and you'll get the proof that we tried to get to in green, where we prove the product of the intercepts are equal. So over to the right here, it's a very similar principle, except we're dealing with secants, and secants is when they extend outside the circle, a chord continues. So in this case, the secant is EY and GY. So EY and GY. We need to prove that E to F times Y to F, so this point here. So just be careful, it's E all the way to Y and then F all the way to Y is equal to G to Y times Y to H. So again, their products are equal. So if you consider this, you need to notice that this angle here, Y, is the same for both triangles that we're going to prove are similar again. Secondly, the angles here, G and E, they are equal because they're subtended from the same arc FH. So we've got two more angles as a pair. And then because you look at it, if you could look at it the other way, the triangle is similar because if two angles are the same, obviously the third will be in matching order as well. So therefore, you've just created similar triangles, EYH and GYF. And in doing so, you match up the sides again like there in the yellow, and you'll find that it proves, because when you cross multiply, we get down here what we tried to prove here. So recapping, they rely on similar triangles. And again, you won't be tested on this, but it is good to know and to help you work through all the different problems.